Hello, my name is Brevan Hurst, and for my presentation today, I've decided to do a special kind of ride. Now this ride appears in two of the Universal parks, Universal Studios with the Carousel, and Universal Epic Universe with the Constellation Carousel. Of course, I'm talking about the carousel. Now, the carousel is a commonplace ride in almost every single theme park across America, with riders placed throughout a large circular ride. As the ride spins, the riders go up and down on horses to simulate a galloping horse. In our particular case, we have a carousel with a 20-foot radius, a rider that's 16 feet away from the center, and a person waiting in line 3 feet away from the actual ride itself. And our person waiting in line wants to find the equation for the distance between him and the rider riding the ride at any given point during the ride. A few things we have to take into note, though, beyond the dimensions of the ride, is the fact that it takes 4 minutes for the ride to make a full revolution around, and 12 minutes for the ride to complete. So with that in mind, we know that our graph must be t must be greater than or equal to 0, and t must be less than or equal to 12, because we will be measuring in minutes for our first graph. So on the x-axis, we will have the variable t, which will be time in minutes, and on our y-axis, we will have d for distance in feet. So with that in mind, we can start to graph to find our equation. So, as I place the numbers here, imagine, as you will, our ride. And as it goes around, our rider gets further and further from the person waiting in line. So, because they are the closest they can be near the start of the ride. So with that in mind, they will start at 7 feet apart during the beginning of the ride. So at t equals 0, d will be 7. And as the ride starts and continues, after 2 minutes, the rider and the person waiting in line will be 39 feet apart. And then as the ride makes a full revolution around, they'll be back at 7 feet apart after 4 minutes. And after 6, they'll be 39 feet apart. After 8, they'll be 7, 10, 39, 12. At the end of the ride, they'll be back at 7 feet apart. So with that in mind, we can draw our line through the points. This looks like a sinusoid. So using this, we can find the equation for our graph. So f of t equals negative 16, and we chose negative because this is a reflected cosine function. Cosine pi over 2, that's our period, 16 being our height or amplitude, x, and we have no horizontal shift, so we have no minus c, plus 23 to show that we had a vertical shift up of 23. Now, not only do carousels go around and around, but they have horses and riders that go up and down. So with that in mind, we can make another graph. And while I'm making this graph, I'd like for you to imagine a horse that has a foot that is 1 foot off the ground. We want to measure the foot because riders' heights can differ. And with this, we have our graph. So t is in seconds this time, and t will be our variable for the x-axis, and h is in feet still, but we chose h to represent height. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And these will be in increments of 1. So, at the start of the ride, which will take 720 seconds, we will be 1 foot off the ground. And then after 1 second, the horse will go up 2 feet, and then after the next second, back down 2 feet, and up and down and up and down, continually all the way up until 720. So using this, we can find our equation, which is F of t equals negative cosine. We have a negative cosine function like we did over here. It's reflected. Pi of x plus 2 to show that we have a midline of 2 and a height of 1, a period of pi, and with that, we have our equation.